We're now looking at normal distributions, example 2.6. All right, so again, once again, it's our job to find a z-score. So that's going to be related to the standard normal bell curve with 0 in the middle. That's standard normal. It talks about the 9th decile. All right, so this goes back a ways. When we talked about deciles, we talked about the fact that the 9th decile is called D subscript 9. The analogy we talked about was the fact that a dime is a tenth of a dollar. In other words, 9/10 of the data. It seemed to make sense to the majority of us to change that into a percentile. So 9/10 of the data would be what? 90% of the data. This is just like 90 pennies is the same as 9 dimes. 90th percentile. Let's put it that way. All right. So how do percentiles work? Well, you have a percentile. If you're at the 90th percentile, that means that 90% of the data falls below your score. So we want to find the z-score that would have 90% of the data to its left, below. All right, you can guess again, but I would hope you would look at it and think, you know what, that z-score is going to be up here in order for there to be 90% below, right? Because here's 50, right? And then some more. So it's got to be on the upper half. If you're at the 90th percentile, you're going to be above the mean, aren't you? Isn't the mean, in fact, the 50th percentile? All right, so here we go. We know that all that area right there is 0.90, 90th percentile. Our table takes things out to 4 decimal places, so I'll put a couple extra zeros there. So 0.9000. All right. Hey, table, got a picture for you. I'm ready, table. Look, that table, again, wants this. This table, the one I want you to understand, always wants this area right here. Not from here to forever, but here to the middle. So you would again look at this, I hope, and you're already ahead of me, which I hope, but you would say, you know what? I know that this much area is 50%, right? That's the entire lower half of the bell curve. So wouldn't this 90th percentile minus the lower half of the curve leave you this middle region? All right, and I think as we progress through the semester, you'll see why, of all the tables that I've taught, this one seems to be the one that people understand the best. Okay? So anyway, that would leave a middle sliver of 40%, otherwise known as 4000. Look at that! Now, I don't know if I heard you guys very well last time, so I'm going to try one more time. Table time. I heard you that time. Good job. Message me if you want me to keep doing this, but that might be the last time we'll do that for a while. I don't know. But anyway, so middle sliver, right? Table happy, table always want middle. I'll leave this on. Okay. So if that middle sliver is 40, just kind of ignore the decimal. 4,000, let's call it. So 4,000, and again, that's not in the body of the table. Again, this is our target number because it's the middle sliver there that the table wanted. I believe if you look over there, you'll discover that 0.3997 is there, as well as 0.4015. And just like we mentioned on the previous example, again, please watch these in order because I build off of previous examples. But in a case like this, you go with the one it's closer to. It's only 3 away from this, whereas it's 15 away from that. This is the one we'll go with. All right, so 0.3997 will line up with 1.28. On a z-score, always be careful with your signs. This would be fine. I wouldn't have any problem with that. Mr. Sandpaper would be totally fine with that. But just for extra, why don't you put a plus sign on it, just to show that you understood it's on the upper half. There it is. That's that one. Let's keep it normal, all right?